Hello everyone. In previous class, we discussed about the oscillator circuit. In this, we discussed about what is the Wien bridge oscillator as well as the crystal oscillator, or we can say that the quartz crystal oscillator circuits. So in this lecture, we will study about the power amplifier. What is it and how it is work. इस लेक्चर में हम देखेंगे कि पावर एम्पलीफायर जो है वो क्या होते हैं, कितने टाइप्स के होते हैं, उनकी क्लासेस क्या क्या हैं और पावर एम्पलीफायर कहाँ कहाँ यूज कर सकते हैं. So second is what is the power amplifier. This is the introductory part. And third topic is the types of power amplifier, or we can say that the classification of the power amplifier. Next we will move on the power amplifier classes. There is so many classes in power amplifier circuit like class A, class B, class C, class AB, etc. So the next topic is the application of the power amplifier in a different sectors. And the last topic is the references of this presentation. So in this lecture, we cover all these topics one by one. So let's start with topic power amplifiers. So the first question is that what is the power amplifier? A power amplifier is an electronic amplifier designed to increase the magnitude of power of a given input signal. The power of the input signal is increased to a level high enough to drive load of output device like speakers, headphone, RF transmitters, etc. Unlike voltage or current amplifier, a power amplifier is designed to drive loads directly and is used as a final block in the amplifier chain. तो नॉर्मल एम्पलीफायर और पावर एम्पलीफायर में क्या डिफरेंस है? पावर एम्पलीफायर को हम इस तरीके से डिजाइन करते हैं कि डायरेक्ट हम एज अ फाइनल ब्लॉक उसको यूज कर सकते हैं एम्पलीफिकेशन चेन में. Next topic is what is the power amplifier? An amplifier is an electronic device used to increase the magnitude of the voltage, current and power of input signal. It takes in a weak electrical signal or waveform and reproduced a similar stronger waveform at the output by using an external power source. एक्सटर्नल पावर सोर्स से कहने का मतलब है नॉर्मल एम्पलीफायर सर्किट जो होता है उसमें हमें एडिशनल डीसी सप्लाई प्रोवाइड करानी होती है और जो हम उसमें इनपुट सिग्नल देंगे आउटपुट में वो हमें उसको बूस्ट करके आउटपुट सिग्नल प्रोवाइड करेगा. सो दिस इज नोन एज द एम्पलीफायर. What is power amplifier? A power amplifier is an electronic amplifier designed to increase the magnitude of the power of a given input signal. Depending on the change aids next to the input signal, amplifiers are broadly classified into current, voltage and power amplifiers. The definition of a power amplifier is an electronic amplifier designed to increase the magnitude of power of a given input signal. The power of the input signal is increased to a level high enough to drive loads of output devices like speakers, headphone, RF transmitter, etc. पावर एम्पलीफायर से हम आउटपुट सिग्नल को इतना ज़्यादा या इनपुट सिग्नल को हम इतना ज़्यादा आउटपुट में बढ़ा के ले लेते हैं कि जिससे कि हमारा जो लोड है वो चल सके या ड्राइव हो सके। The input signal of a power amplifier need to be above a certain threshold. So instead of directly passing the raw audio RF signal to the power amplifier, it is first pre-amplified using current voltage amplifiers and is sent as input to the power amplifier after making necessary modification. You can observe the block diagram of the audio amplifier and the uses of power amplifier below. So this is the diagram of audio amplifier. ये हमारा इनपुट है, माइक है जिससे हमें अपनी वॉइस को जो है वो एम्पलीफाई करके स्पीकर तक भेजना है। तो सबसे पहले हमने यहाँ पे माइक का यूज किया है। दिस इज कॉल्ड दी प्री एम्पलीफायर। आफ्टर दिस द सिग्नल मूव टू द वोल्टेज एम्पलीफायर, देन टोन एंड वॉल्यूम कंट्रोल, देन दी पावर एम्पलीफायर, और आउटपुट में हमें जो एम्पलीफायर सिग्नल है वो मिल जाएगा। मीन्स नॉर्मल सिग्नल जो होता है डायरेक्ट हम उस सिग्नल को सीधे पावर एम्पलीफायर में नहीं भेजते, पहले हम उसको एम्पलीफाई कर लेते हैं प्राइमरी स्टेज पे, और बाय यूजिंग वोल्टेज और करंट एम्पलीफायर के थ्रू हम सिग्नल को पहले एम्पलीफाई कर लेते हैं और ये एम्पलीफायर सिग्नल हम पावर एम्पलीफायर के इनपुट में देते हैं। सो आउटपुट में हमें जो है वो हाई एम्पलीफाइड सिग्नल मिलता है। ठीक है, सिंपल डायग्राम है ये, ब्लॉक डायग्राम ऑफ एन ऑडियो एम्पलीफायर कि ऑडियो को हम कैसे एम्पलीफाई करते हैं। In this case, a microphone is used as an input source. The magnitude of signal from the microphone is not enough for the power amplifier. So first, it is pre-amplified where its voltage and current are increased slightly. Then the signal is passed through tone and volume control circuit, which makes aesthetics adjustment to the audio waveform. Finally, the signal is passed through a power amplifier and the output from power amplifier is fed to a speakers. The next topic is the types of power amplifiers. Depending on the types of output devices that is connected, power amplifier are divided into the following three types. Number one is a audio power amplifier, number two is radio frequency power amplifiers, and number three is DC power amplifiers. तो ये जो क्लासिफिकेशन है डिपेंड करता है कि आउटपुट डिवाइसेस कौन सी है। So number one is audio power amplifier. This type of power amplifier are used for increasing the magnitude of power of a weaker audio signal. The amplifier used in speakers, driving circuitries of televisions, mobile phones, etc. come under this categories. तो ऑडियो पावर एम्पलीफायर में हम किसको एम्पलीफाई करते हैं? ऑडियो सिग्नल को, या सिंपल लैंग्वेज में बोले हम तो साउंड सिग्नल को। The output of an audio power amplifier ranges from a few milliwatts like in headphones amplifier to thousands of watts like a power amplifier in hi-fi home theater systems. तो जो फ्रीक्वेंसी रेंज होती है या एम्पलीफिकेशन रेंज होती है पावर सिग्नल की, वो मिलीवॉट से लेके थाउजेंड्स ऑफ वॉट्स तक हो सकती है इन केस ऑफ ऑडियो पावर एम्पलीफायर सर्किट्स। Next is a radio frequency power amplifiers. Wireless transmissions require modulated wave to be sent over long distance by air. The signals are transmitted using antennas and the range of the transmission depend on the magnitude of power of signals feed to the antenna. For wireless transmission like FM broadcasting, antennas require input signals at thousands of kilowatts of power. Here, the radio frequency power amplifier are employed to increase the magnitude of power of modulated wave to a level high enough for reaching required transmission distance. जो रेडियो फ्रीक्वेंसी पावर एम्पलीफायर्स हैं उनका यूज हम कहाँ करते हैं? ब्रॉडकास्टिंग में, एफएम ब्रॉडकास्टिंग एज वेल एज एएम ब्रॉडकास्टिंग. Next, third one is DC power amplifiers. The DC power amplifiers are used to amplify the power of a PWM, means pulse width modulated signal. They are used in electronic circuits or electronic control systems which need high power signal to drive motor or alternators. They take input from microcontroller system and increase its power and feed the amplified signal to a DC motor or actuators. Next is the power amplifier classes. There are multiple ways of designing a power amplifier circuits. The operation and output characteristics of each of the circuit configurations differ from each other. To differentiate the characteristics and the behavior of different power amplifier circuits, the power amplifier classes are used. तो classes का main use क्या है? Classes के through हम जो डिफरेंट टाइप के हमारे पास एम्पलीफायर हैं उनकी कैरेक्टरिस्टिक्स और बिहेवियर को स्टडी कर सकते हैं. In which letter symbols are assigned to identify the method of operation. क्लास को डिफाइन करने के लिए हमने लेटर्स का यूज किया है. A, B, A, B, C. This is called the example of classes of the amplifier. They are broadly classified into two categories. First one is called the power amplifier designed to amplify analog signal, come under A, B, AB or C categories. Number two is power amplifier designed to amplify pulse width modulation, in short PWM. Digital signals come under D, E, F, etc. तो एनालॉग सिग्नल है जो किस कैटेगरी या किस क्लास के अंदर आते हैं? ए, बी, ए बी और सी कैटेगरी के अंदर. और जो डिजिटल सिग्नल जो आते हैं वो डी, ई, एफ एंड सो ऑन कैटेगरीज के अंदर आते हैं. The most commonly used power amplifier are the one that are used in audio amplifier circuits, and they come under the class A, class B, class AB or class C. So let's take a look at them in detail. So the power amplifier classes are broadly classified into two categories. First one is a power amplifier designed to amplify analog signals, come under A, B, and C category. And number two, amplifier designed to amplify PWM, or we can say that pulse width modulation digital signals, come under D, E or F categories. So the power amplifier classes is class A power amplifier, class B, class AB, class C and some other power amplifier classes. So the first one is a class A power amplifier. Class A amplifier are the most common type of amplifier topology, as they use just one output switching transistor within their amplifier design. This single output transistor is biased around the Q point within the middle of its load line and so is never driven into its cutoff or saturation region, thus allowing it to conduct current over full 360° of the input cycle. Then the output transistor of a class A topology never turn off, which is one of its main disadvantage. So this is the diagram of the class A amplifier and the input as well as the output signal of the class A power amplifier circuit. The class A amplifier are considered the best class of amplifier design due mainly to their excellent linearity, high gain and low signal distortion levels when designed correctly. Although seldom used in high power amplifier applications due to thermal power supply consideration. Class A amplifiers are probably the best sounding of all the amplifier classes mentioned here and as such are used in high fidelity audio amplifier designs. To achieve high linearity and gain, the output stage of a class A amplifier is biased on all the time. Then for amplifier to be classified as class A, zero signal idle current is in the output stage must be equal or greater than the maximum load current required to produce the largest output signal. As a class A amplifier operates in the linear portion of its characteristics curve, the single output device conducts through a full 360° of the output waveform. Then the class A amplifier is equivalent to a current source. Since a class A amplifier operates in a linear region, the transistor base DC biasing voltage should be chosen properly to ensure correct operation and low distortion. However, as the output device is on at all the time, it is constantly carrying current, which represent a continuous losses of power in the amplifier. Due to this continuous losses of power, class A amplifier create tremendous amount of heat adding to their very low efficiency at around 30%, making them impractical for high power amplification. Also, due to the high idling current of the amplifier, the power supply must be sized accordingly and be well filtered to avoid any amplifier hum and noise of the circuit. तो चूंकि हमारे जो पावर लॉसेस जो हैं क्लास ए एम्पलीफायर में वो कंटिन्यू होते रहते हैं और हाई अमाउंट ऑफ हीट क्रिएट करते हैं जिससे कि इसकी एफिशिएंसी है बहुत ही कम होती है 30% होती है, तो ये जो है वो थोड़ा प्रैक्टिकली ज़्यादा यूज़ हम इसको नहीं करते. Therefore, due to the low efficiency and overheating problems of class A amplifier, more efficient amplifier classes have been developed. Next is class B power amplifier. Class B amplifier were invented as a solution of the efficiency and heating problem associated with the previous Class A amplifier. The basic Class B amplifier uses two complementary transistors, either bipolar or field effect transistor for each half of the waveform, with its output stage configured in a push-pull type arrangement, so that each transistor device amplifies only half of the output waveform. तो क्लास बी में क्या किया, अभी हमने क्लास ए में ओनली वन ट्रांजिस्टर कनेक्ट किया था, इसमें हमने दो ट्रांजिस्टर या एफईटी हमने कनेक्ट कर दिए, पॉजिटिव हाफ साइकिल के लिए सेपरेट ट्रांजिस्टर और नेगेटिव हाफ साइकिल के लिए सेपरेट ट्रांजिस्टर ऐड कर दिया है. In the class B amplifier, there is no DC base bias current as its consequent current is zero, so that the DC power is small and therefore its efficiency is much higher than that of the class A amplifier. However, the price paid for the improvement in the efficiency is in the linearity of the switching device. This is the circuit diagram of the class B power amplifier and its characteristics. When the input signal goes positive, the positive bias transistor conduct, and while the negative transistor is switched off. Likewise, when the input signal goes negative, the positive transistor switch off while the negative bias transistor turn on and conduct the negative portion of the signal. Thus, the transistor conduct only half of the time either on positive or negative half cycle of the input signal. So this is the diagram of class B amplifier. इसमें हमने हर जो हमारी पॉजिटिव और नेगेटिव हाफ साइकिल है दोनों के लिए सेपरेट ट्रांजिस्टर यूज किया हुआ है. Then we can see that each transistor device of the class B amplifier only conduct through one half or 180 degree of the output waveform is strict time alternation. But as the output stage has devices for both halves of the signal waveform, the two halves are combined together to produce a full linear output waveform. This push-pull design of amplifier is obviously more efficient than the class A at about 50%, but the problem with the class B amplifier design is that it can create distortion at the zero crossing point of the waveform due to the transistor dead band of the input base voltage from 0.7 volt to plus 0.7 volt minus 0.7 volt to plus 0.7 volt. We remember from the transistor tutorial that it takes a base emitter voltage of about 0.7 volt to get a bipolar transistor to start conducting. इसको हम cut in voltage भी बोलते हैं जो कि 0.7 होता है. Then in a class B amplifier the output transistor is not biased to an on state of operation until this voltage is exceeded. मतलब जब तक कि 0.7 वोल्ट से ज़्यादा वोल्टेज नहीं होगा तब तक हमारा ट्रांजिस्टर ऑन नहीं होगा. तो ये इसका ड्रॉबैक है क्लास B एम्पलीफायर का. This means that the part of the waveform which falls within this 0.7 volt window will not be reproduced accurately, making the class B amplifier unsuitable for precision audio amplifier application. To overcome the zero crossing distortion, class AB amplifier were developed. As its name suggests, the class AB amplifier is a combination of the class A and the class B type amplifier we have looked at above. The AB classifications of amplifier is currently one of the most common used types of audio power amplifier design. The class AB amplifier is a variation of a class B amplifier as described above, except that both devices are allowed to conduct at the same time around the waveform crossover point, eliminating the crossover distortion problems of the previous class B amplifier. The two transistors have a very small bias voltage, typically at 5 to 10% of the consequent current, to base the transistor just above its cutoff point. Then the conducting device, either bipolar of FET, will be on for more than one half cycle but much less than one full cycle of the input signal. Therefore, in class AB amplifier design, each of the push-pull transistor is conducting for slightly more than the half cycle of the conduction in class B, but much less than the full cycle of the conduction of class A. In other words, the conduction angle of a class AB amplifier is somewhere between 180 degree and 360 degree, depending upon the chosen base or chosen bias point as shown. So this is the diagram of class AB power amplifier, or we can say that this is the combination of class A and class B amplifier. The advantage of this small bias voltage provided by series diode or resistors is that the crossover distortion created by the class B amplifier characteristics is overcome without the inefficiency of the class A amplifier design. So the class AB amplifier is a good compromise between class A and class B in terms of efficiency and linearity, with conversion efficiency reaching about 50 to 60%. So the next is class C power amplifier. The class C amplifier design has the greatest efficiency but the poorest linearity of the classes of amplifier mentioned here. The previous classes A, B and AB are considered linear amplifiers, as the output signal, amplitude and the phase are linearly related to the input signal amplitude and phase. However, the class C amplifier is heavily biased so that the output current is zero for more than one half of the input sinusoidal signal cycles, with the transistor idling at its cutoff point. In other words, the conduction angles of the transistor is significantly less than 180 degree and generally around the 90 degree area. While this, from a transistor biasing, given a much improved efficiency of around 80% to the amplifier, it introduced a very heavily distortions of the output signal. Therefore, the class C amplifier are not suitable for use as audio amplifier. This is the diagram of class C amplifier and its operating characteristics. Due to its heavy audio distortion, the class C amplifier are commonly used in high frequency sine wave oscillators and certain type of radio frequencies amplifier, where the pulse of current produced at the amplifier output can be converted to complete sine wave of a particular frequency by the use of LC resonant circuit in its collector circuits. Next topic is amplifier classes summary. Then we have seen that the quiescent DC operating point Q point of an amplifier determine the amplifier classification by setting the portion of Q point at the halfway on the load line of the amplifier characteristics curve. The amplifier will operate as a class A amplifier, and by moving the Q point lower down the load line, change the amplifier into a class AB, B or C amplifier. Then the class of the operation of the amplifier with regard to its DC operating point can be given as amplifier classes and the efficiency. So as well as audio amplifier, there are a number of high efficiency amplifier classes relating to switching amplifier design that use different switching techniques to reduce power losses and increase the efficiency. So this is the diagram for amplifier classes and their efficiencies. Class A amplifier, the efficiency is 30% or 35%. AB approximately 50 to 60%, C 70 to 75%, and D or T amplifier is 100% efficient. As well as audio amplifier, there are a number of high efficiencies amplifier classes relating to switching amplifier design that use different switching techniques to reduce power losses and increase efficiency. Some amplifier classes design listed below use RLC resonators or multiple power supply voltages to reduce power losses, or are digital DSP type amplifier which use pulse width modulation switching techniques. The next topic is other common amplifier classes. इसके अलावा भी कुछ एम्पलीफायर की क्लासेस हैं, वो हम देखते हैं. So next is a class D amplifier. A class D audio amplifier is basically a non-linear switching amplifier or PWM amplifier. The class D amplifier theoretically can reach 100% efficiency, as there is no periodic during a cycle where the voltage and the current waveform overlap, as the current is drawn only through the transistor that is on. Next is the class F amplifier. So class F amplifier boosts both efficiency and the output by using harmonic resonators in the output network to shape the output waveform into a square wave. Class F amplifier are capable of high efficiencies of more than 90% if infinite harmonic tuning is used. Next is a class G amplifier. Class G offer enhancement to the basic class AB amplifier design. Class G uses multiple power supply rails of various voltage and automatically switches between these supply rails as the input signal change. This constant switching reduces the average power consumptions and therefore the power losses caused by wasted heat. Next is the class I amplifier. The class I amplifier has two sets of complementary output switching devices arranged in a parallel push-pull configurations, with both set of switching devices sampling the same input waveform. One device switching the positive half cycles of the waveform while the other switches are the negative half cycle, similar to a class B amplifier, with no input signal applied, or when a signal reaches to the zero crossing point, the switching devices are both tuned on and off simultaneously with a 50% PWM duty cycle, cancelling out any high frequency signals. To produce the positive half of the output signal, the output of the positive switching device is increased in duty cycle while the negative switching device is decreased by the same and vice versa. The two switching signals currents are said to be interleaved at the output, giving the class I amplifier the name of interleaved PWM amplifier, operating at switching frequency in excess of 250 kHz. Next is a class S amplifier. So a class S power amplifier is a non-linear switching mode amplifier similar in operating to the class D amplifier. The class S amplifier convert analog input signals into a digital square wave pulse by a delta sigma modulators and amplify them to increase the output power before finally being demodulated by a bandpass filter. As the digital signal of this switching amplifier is always either fully on or off, efficiency reaching 100% are possible in this class of amplifier. Next, the class T amplifier. The class T amplifier is the another type of the digital switching amplifier design. The class T amplifiers are starting to become more popular these days as an audio amplifier design due to the existence of digital signal processing chip and multi-channel surround sound amplifier, as it is convert analog signal into the digital pulse width modulation signals for amplification, increasing the amplifier efficiency. The class T amplifier design combine both the low distortion signal level of the class AB amplifiers and the power efficiency of the class D amplifier. So ये जो हमारे कुछ other type के classes हैं, exam point of view से उतने important नहीं हैं, class D, class E, class F, class I, class S और class T amplifier. एग्जाम पॉइंट ऑफ व्यू से आपके लिए जो डिटेल में आपको समझना है वो है क्लास ए, क्लास बी, क्लास सी एंड क्लास ए बी. इनको बहुत ही अच्छे से आपको स्टडी करना है. We have seen a number of classification of amplifiers ranging from linear power amplifier to non-linear switching amplifiers and have seen how an amplifier classes differ along the amplifier load line. The class AB, B and C amplifier can be defined in terms of conduction angle theta as follows. So this is the table: class A, class B, class C, class AB and class D to T. So in a class A, full cycle 360 of the conduction. So the conduction angle theta is equal to 2 pi. In case of class B, theta is equal to 180 degree or theta is equal to pi. In class AB, the theta is lie between the pi to 2 pi. And class C, the theta is less than 2 pi, means 180 degree, and class D to T, the theta is equal to 0. Now the next is the applications of power amplifier. The application of power amplifier in a different sector in a consumer electronics. Audio power amplifiers are used in almost all consumer electronic devices ranging from microwave oven, headphones, drivers, televisions, mobile phones and home theater system to theoretical and concert reinforcement system. Second is the industrial. Switching type power amplifier are used for controlling most of the industrial alternator systems like servo and DC motor. Wireless communication. High power amplifiers are important in transmission of cellular or FM broadcasting signal to users. Higher power levels made possible because of power amplifier increase the data transfer rates and usability. They are also used in satellite communication requirements. तो ये हमारा पावर एम्पलीफायर के कुछ एप्लीकेशन और यूज हमने देखे. Next is references. So these are the references of this presentation. And thank you for watching this video.